Hello students, welcome back to this channel. So in this video we are going to be handling or starting the series of pure mathematics, specifically in Form 5. Now a disclaimer here, in Form 5 we are going to be handling and solving questions the old curriculum way, but when you're setting items they are going to be in terms of essay formats. So here the data was specifically extracted for you, but in an exam or in an assessment, we shall be providing the data in terms of items where you have to extract out that data, and then you use it according to the knowledge you're learning here to solve the numbers. So in this video, we're going to be starting with Surds and Indices, and it's under Pure Mathematics, presented to you by Walgembe Yusuf. Now looking at surds, surds as a definition, we are going to define surds or a surd as a number which is going to be in the form of b and the root of a. But this b is going to initially be inside this root, and you are going to see how we are going to be extracting them out. Now the a is going to be under a root, but this a value must not be a square number, or it must be prime number without any specific root to it. So you're saying that a surd is a number which is going to be in this format, where a is not a perfect square. And also, surds can be multiplied and divided in the following formats. So if at all you're multiplying two surds, in other words, if at all you're multiplying two figures or two values, each under square root, we assume that since both of them are under square root, so during multiplication, we unify the square root and then we multiply what is inside the roots. So square root of a times square root of b is the same as square root of a b, or is the same as square root of a times b. Now secondly, square root of a divided by b can also be combined. So it's only multiplication and division where we combine these roots. No, you should put an emphasis there. It's only multiplication and division where we combine roots. Subtraction and summation, we do not combine the roots. So division is also the same as unifying the same square root and then dividing what is inside, a divided by b. But this is only going to apply for multiplication and division strictly. That's why we say that, but for root of a plus root of b is not the same or is not equal to a plus b, because in addition we do not unify the roots, and same to subtraction. So you may also add another example here. Also root of a minus root of b is not equal to root of a minus b. Try to include that in your notes. So on the third point, we are saying that two sides are going to be said to be conjugate to each other if their product is a rational number. Now we are going to look at this. For example, if you're having root 2 and root 2 and are conjugate sides, they're going to be conjugate sides because when you multiply them, you are going to get a value which is inside the root. So that is called the conjugate side, but this is not that important. Though in teaching you may hear me talking about them. So if at all you're multiplying a root and another root, we call those ones conjugate sides. A root of a specific number times a root of another specific number gives you the number which is under the square root. So root 2 times root 2, you get 2. Or you can use the concept that we used before that, you unify the root, so it's going to be root 2 times 2 under the same root, and then you're going to end up with 4. And then root 4 is going to give you a value of 2. Now similarly, if at all, when you're talking about conjugates, for conjugates in surds is that you get the number with a square root, and then to get its conjugate, you change the sign on the which is nearing this value under the square root. So here you can see that it's 2 minus root of 3. So the next sign to the root is negative. So when you're getting the conjugate of this, we change this sign to a positive, and that's how we get conjugates. And you're going to be using this one specifically under the concept of rationalization, and you're going to look at numerous examples under that. So the conjugate of 2 minus 3, we just change the sign in the middle to 2 plus 3. And therefore, it's going to 2 minus root of 3 is going to be a conjugate base of 2 plus root of 3. And they are considered to be conjugate to each other. Now notice that here, also the term that you're going to be commonly using in our calculations is, when you're rationalizing, you're going to have a term like this. Now remember that this one is the same as a difference of two squares, and you're going to hear me talking about it often, whereby you're having a minus b, bracket of a minus b into the bracket of a plus b. I hope you looked at that in your O level, and you're told that this is going to be a difference of two squares. So that's why simplifying this, all this can be written in the form of 2 squared, where 2 is your a, and then minus root of 3 squared, where root of 3 is going to be your b. So you should note this, and you should understand it right away, that when you see two conjugates multiplying each other, when they have 2 digits, it's going to be a difference of 2 squares. So it's the same as 2 squared minus root of 3 squared. But when you square root of 3, you get the same value. You get 3. And when you square 2, you get 4. So 4 minus 3 is going to give you 1. Now looking at another concept, let's look at rationalizing the denominator of a fraction, and which can be given as a rational number under the following examples. So with the first example, we are going to simplify. Simplifying 3 root of 2 plus 5 root of 3 plus 7 root of 2 minus root of 3. Now remember that I told you there is no unifying roots in addition and subtraction. So what we do, since we don't combine roots in addition and subtraction, we are going to collect terms that are having the same roots. For example, in the simplification that you are doing, you can see that you are having 3 root of 2. Also here you can see that you are having 7 root of 2. So we bring those figures that are having the same roots together, and then you end up with 3 root of 2 plus 7 root of 2. We have gathered these ones, or we have collected like terms. And then plus, then you also remain with the other terms that are having root 3. So you're going to remain with 5 root of 3 minus root of 3. So what you do here is that we don't ignore, but we consider these root of 2's. We don't add them. The simplest way is to prime factorize out them. But I don't know whether you can understand that English right now. But what you need to know here is that in addition, we just add coefficients. We don't tamper with the roots. You leave the roots alone and you just add the coefficients. So here 3 root of 2 plus 7 root of 2, we just add the coefficients, that is going to be 3 plus 7, and then we multiply it with the root in which it is attached to. So we consider this one as unknown. So for example, if you say that root 2 is going to be x, it's going to be the same as 3x plus 7x. If at all you are to say that, let root of 2 be x. So it's the same concept we use here. So 3x plus 7x is going to give you 10x, which is good. That's why we wrote here 10 root of 2. Then the same thing applies here. If at all root of 3 is the same as y, so you're going to have 5y minus y. And then you're going to end up with 4y. So that's why we are having 4 root of 3. Then after that, for further simplification, you can see that both of these values, 10 and 4, they are having a common factor, and that common factor is going to be 2. So we prime factorize out 2, and then in the bracket you are going to remain with 5 root of 2 plus 2 root of 3. Now proceeding, we are going to be expressing the following in their simplest forms. Now here we are going we are expressing these ones in the simplest surd format, whereby we are going to talk about this. So first of all, we are going to express root of 8 in its simplest form, root of 20, root of 90, and then root of 18. Now the first step in doing this is that whichever value you are given, you are supposed to get any square number that value has. So for example, 8. 8 has a square number of 4 within it, or one of its common factors is going to be, or multiples is going to be 4, and 4 is a square number. So upon getting that square number, which other value can you multiply it with to get the same value? So for me to get back the 8, I'll multiply it with 2. So that's how, so 8 is the same as 4 times 2. But whichever values that you have chosen, they must be 2, and one of them must be a square number. So if you look at 20, also 20 has one of its multiples to be 4, and 4 is a square number. So what can I multiply 4 with to get 20? So I can multiply it with 5. That's the trick. You get one must be a square number, and the other one must be a non-square number. So if you look at 90, which square numbers can you multiply to get 90? It's going to be 9 times 10, because 9 is a square number and 10 is not a square number. In other words, you're talking about numbers with square roots, if I talk about square numbers. So when you come to root of 8, you say that root of 8 is going to be, you first express 8 in terms of its factors. So 8 is the same as, you get a square number multiplied by a non-square number. So it's going to be 4 times 2. But remember that we told you that when you see this multiplication means that all the values inside that root can have their individual roots, or we can separate them. So root of 4 times 2 is the same as root of 4 multiplied by root of 2. And then root of 4 is the same as 2. Root of 2 does not have a square root, so it's going to be 2 times root of 2, and you end up with the answer of 2 root 2. I hope you have understood that. And if you're understanding, or if you're having any issues, you leave your comments, you leave your issue in the comment section. And if you're understanding, you like the video, so that I know whether there is progress or not. Now when you're proceeding to part B, you're going to get root of 20, or we are simplifying root of 20. So first we get a square number or a square multiple under 20. So 20 has a square multiple of 4. So what can you multiply 4 with to get back the 20? We can multiply it with 5. After that, we separate these two figures under their own roots. So it's going to be root of 4 times root of 5. But root of 5 does not have a square root. We leave it as it is. But 4 has a square root, and then we give it as 2. So proceeding to root of 90, you can see that 90 has multiples of 9 is a square number. So we find any other digit we can multiply 9 with to get the 90, and it's going to be 10. So we separate the roots, it's going to be root of 9 times root of 10. After that, root of 9 is the same as 3. Root of 10 is going to remain the same. So here we made a mistake. It's not supposed to be root of 2, but it's supposed to be root of 10. So same applies to 18. 18 has which square number? So you find that one of the multiples of 18 is going to be 9, and 9 is a square number. So you get 9, and we find any other value you can multiply 9 with to get back the 18, and it's going to be 2. After that, you separate the roots, and you get 3 multiplying root of 2, and then you end up with an answer of 3 root of 2. Now proceeding, we are going to be expressing the following in terms of a single side. So here, the other side, here, in this case, we are going to be doing the reverse of the previous example. So we want this one to be under everything under the root. So what we are going to do is that we are going to be doing the reverse of what you are doing. So 3 root of 2 in terms of a single side is going to be the same as if you bring back these 2 into a root, you give it a square. Remember that for us to do the other previous example, we are getting a square number. And to get a square number from this number outside the bracket, we have to square it, and then we bring it back under the root. So 3 root of 2, for us to bring back 3 under the root, we have to square it first, and then multiply it by 2. So we simplify it, 3 squared by getting 9. So 9 times 2, you get root of 18. So we are simply reversing what we did in the previous example. So 4 times root of 6, to bring back this 4 into the root, we have to square it, and then times 6. So 4 squared is the same as 16. So it's going to be 16 times 6 under the root. And then you're going to end up with root of 96. Same applies to 2 root of 3. We have to square the 2 for us to bring it back under the root. And then you multiply it with 3. And then you end up with root of 4 times 3, which is going to give you root of 12. So in the following examples, you're also going to be simplifying the following, looking at multiplication of sides. Now multiplication of sides is going to remain the same as the usual multiplication, although here we are going to include in some terms. So first, we are going to be evaluating the following. We are first part A, we are going to be multiplying 3 root of 2 multiplied by 2 root plus root of 3. And then in part B, we are going to be squaring root of 2 and plus root of 3. Now in items, plus sign is going to either mean and the product sign, we are going to tell you that this one was multiplied with this one, but we got a product of this and this. So you have to extract all that information by your own. You should know that. Here I'm just teaching you how to solve after you're extracting out the data, but later we are going to present some items to be attempted and the guides are going to be posted. So looking at the solution of part A, so what you do, just like you did in your O-level, 3 is going to multiply this bracket and as well root of 2 is going to multiply this bracket. So that's the first step. We start by separating either of them. So here when you're multiplying, 3 times 2 is going to give you 6. But when you're beginning, we told you that if at all you're having two numbers under a root and they're multiplying each other, both of them, you get a uniform bracket, which is a B. But if at all you're having any digit which is outside a root multiplying a number which is inside the root, this digit cannot multiply the number inside the root, but rather it becomes a coefficient of that root. So if you're having 3 times root of 3, you're going to get 3 root of 3. 2 times root of 2, you're going to get 2 root of 2. This digit cannot enter into this root. I hope you understand that. So 3 times root of 3, you get 3 root 3. 2 times root 2, you get 2 root 2. And then root 2 times root 3. So these ones are all under roots. So that means that we combine the roots and then we multiply what is inside. So it's going to be root 2 times root of 3 is the same as root of 2 times 3, which is going to give you root of 6. So looking at part B, part B we are squaring this same bracket. So when you're squaring this same bracket, it means that it's going to be this bracket multiplying its very bracket. So it's going to be bracket of this multiplying the bracket of that. So what we do is that we get this root 2 has to multiply this whole bracket, also this root of 3 has to multiply this whole bracket. So after that, we are going to unify them onto the same line. So it's going to be root 2 multiplying the bracket of root 2 plus root of 3. And then root of 3, which is here, multiplying the same bracket. And then we use the same principles. So if you look here, each and every number is under root. That means that we are going to be multiplying them all separately inside the roots. So root 2 times root of 2, we unify the roots since both of them are inside the roots. So it's going to be root of 2 times 2. And it's going to be root of 4, and then you're going to end up with 2. I hope you remember that. And then root of 2 times root of 3, since both of them are under roots, you unify them under single root and then you multiply what is inside. So 2 times 3 is going to give you 6. That's why you're having 6 root of 6. And then root of 3 times root of 2 is also going to give you root of 6. And then root of 3 times root of 3, this is the same as conjugate multiplying a conjugate. Or is the same as root of 3 squared. You are going to get 3. So you add like terms. 2 plus 3 is going to give you 5. And then root of 6 plus root of 6. Remember that here I told you that in addition, we do not add what is inside the roots, but rather we add the coefficients. So assuming that our root of x is the same as y, so in that bracket you're going to have y plus y. So you're going to end up with 2y. So if you're going to end up with 2y, it means that our y is going to be root of 6. And that's why you're seeing here, we're having 2 root of 6. You should pay attention to distinguishing between, for addition and subtraction, we don't tamper with what is inside the roots. It's only with multiplication and division. So let's rationalize the following that are going to be involving denominators. So part A, we are going to rationalize 1 out of root of 2. Part B, we look at that. Part C, that. Part D, that. And part E, that. And part F, that. So part A, rationalizing or simplifying. Now in A level, we do not leave surds in the denominator. So sometimes you may calculate and then you may end up with your answer being in this format. But in A level, the final answer must not be in such format. So what do? We do what we call rationalization. And when you're having a single digit, if you're having a single digit like this, its conjugate is also going to be that very digit. So for us to rationalize 1 out of root 2, we have to multiply the denominator by the same root, which is going to be root 2. We also multiply the numerator by root of 2. So 1 times root of 2, you're going to end up with root of 2 in the numerator, and then root 2 times root 2, you're going to end up with 2, because the same as root 2 squared, which is the same as a figure of 2. So this is your final answer for part A. That's how we rationalize figures or values that have a single square root beneath them. Now let's look at others that are going to have more than one value in the denominator. Now looking at part B. Now remember here I told you that for you to get a conjugate, when you're having two digits or two values, you just change the sign of what is in the middle, and it must be close to the square root. So if you're having 3 minus root of 2, you end up with 3 plus root of 2. That's how you find the conjugate. And the conjugate you get, you multiply it both in the denominator together with the numerator. It must be the same conjugate. So that's how we rationalize. So if you're having 3 minus root of 2, the conjugate is going to be 3 plus root of 2. And also, you multiply it by the denominator, you also multiply it by the numerator. So 1 times the numerator, you're going to end up with the same concept. But remember that here, let me make some emphasis here. Remember that here in your denominator, now we have the other term which I told you above about difference of two squares. You're having 3 minus root of 2, you're also having 3 plus root of 2. So this one is the same as a minus b into a plus b. So if at all you're having a difference of two squares, that means that it's going to be 3 squared minus b squared if you condense it. So your a is going to be 3 and then your b is going to be root of 2. I hope you have understood that. So you end up with 3 plus root of 2 divided by 9 minus 2. And then you're going to end up with the final answer of 3 plus root of 2 divided by 7. So in part C, we are going to do the same format. Rationalizing this, the conjugate, you get the conjugates from the denominator. We don't get it from the numerator. We use the denominator to get the conjugate. So if I tell you having 2 minus root of 3, here you're going to have 2 plus root of 3. And then you multiply that by the numerator. After that, we try to simplify. So it's going to be this bracket multiplying the downer bracket. But the downer bracket is the difference of two squares. So it's going to be 2 squared minus root of 3 squared, which is going to give you 4 minus 3. And then the upper bracket, after simplifying, you're going to get this, though I skipped some steps. So after that, you're going to end up with 7 plus 4 root of 3 divided by 1. And then your final answer is going to be that. So part B and part C, part B is in the same format. The conjugates, you just change the sign which is down here. And then you simplify, you solve, you follow you understand that the denominator having a difference of two squares, you simplify your work in the numerator and the denominator, and then you're going to end up with the following answer. Now in part E, you notice that you are having two different values. So if you're having two different values, you first rationalize each and every value separately. So that's why in my solution you are seeing that I first rationalized this fraction separately, I also rationalized this fraction separately. And when you rationalize this one separately, you are going to end up with 3 plus root of 2 divided by the difference of two squares, which is the same as 3 squared minus root of 2 squared. And it's going to give you 9 minus 2. And the same applies to this side. So rationalizing, you should always remember, now there was a mistake here in this sign. It would have been negative. Rationalizing, you should always remember that you just change the sign of which is close to the square root sign. If it was positive, your conjugate is going to be negative. If it was negative, your conjugate turns to a positive. And then you end up simplifying this, and then you get your final answer. Now with this, there are some circumstances whereby you're going to be given more than one square root. For example, here we are given about 3 square roots. So for this is quite sensitive and you need to pay extra attention here. So what you do is that you first bracket the last 2 roots in the denominator. So after bracketing them down like I did here, you make them to be a single value. So that's why here I say that let p be equal to these roots. So if I tell p is equal to both of those roots, I'm going to remain with root of 2. You remain with root of 2 divided by root of 2 plus p. So this one gets easier to rationalize. So when you're rationalizing this one, we simply get this, we change a change of sign from positive to negative. So you're going to have root of 2 plus p. Its conjugate is going to be, here we start rationalizing right away, and then we get rid of the root in the denominator. That's the first step. So you're going to have root of 2 minus p, and then you also multiply this same bracket with the numerator. Then after that, if you multiply root of, in the numerator, if you multiply root of 2 times root of 2, you're going to end up with 2. And if you multiply negative p with root 2, you're going to end up with minus p root of 2. I hope you have seen that. But in the denominator, it's always going to be a difference of 2 squares. I hope you now see that because I've over mentioned it a lot of times. Many of you fail to see it and then you just waste time expanding the denominator. So difference of 2 squares in the denominator is going to be root of 2 squared, which is the same as 2, then minus p squared, which is the same as that. Now after saying that in your denominator you no longer have a root, so we bring back our substitution of p. So we substitute back our p. So our p is going to be, so here in the next step I was substituting back for the value of p only, which was the same as root of 3 minus 5. Now after that, we expand this bracket. Remember that expansion of this bracket, we have not yet taught you quadratics, but you understand how I got straight out to here. But expanding that bracket is going to involve you to multiply that bracket with another bracket, and you have already done that. So you can spare your time, or you can first pause the video and you try to expand and you see whether you're going to come up with this very answer which is present in this bracket. So now after here, we have to open these brackets. So notice that here we are having 3 plus 5, you are going to get 8. So 8, so it's going to be 2 minus 8, and then you're going to end up with negative 6. And then this negative here times this negative 2 root 6, you're going to end up with plus 2 root of 6. Like I've said, try to expand out this and you see whether you get this bracket. First pause the video and work out that. Then after simplifying your denominator, you're going to end up with this value. Now you can see that in our denominator now, we have got back the root. So rationalizing is about getting rid of the roots in the denominator. So that means that we have to do the second rationalization. We have to do the second rationalization to get rid of this root which has reappeared back in our denominator. And how are you going to do that? We simply get the opposite sign. To get the conjugate, we get the opposite sign of what is there. So that's why you are seeing that here. I say that the conjugate is going to be negative 6 minus 2 root of 6. So you multiply the conjugate both in the denominator together with the numerator. Then after that, you simplify your numerator according to the knowledge you have said it. Now, according to this knowledge, it's going to be 2 times this bracket, also minus root of 6 times this bracket, also plus root of 10 times this bracket. I said that try to expand these things out on your own so that the lessons stick. So you're going to end up with this in your numerator. And then in the denominator, always remember that it's going to be a difference of 2 squares. So negative 6 squared is the same as 36. And then 2 root of 6 squared is going to be the same as 24. So after that, you simplify your denominator, you're going to get 12. Simplifying the numerator, you're going to end up with this. And then later, after simplifying everything, you're going to end up with your final answer to be this. Now, after covering all that, sides are going to said to have come to an end. So this is going to be assessment exercise. You try it out and then you present your answers or you present your ideas. Now for items and for assessments, you can reach me out. But you first try this out so that you can get the working approach before getting the items to extract out the data in this format that you are going to use for practice. So this is also a continuation of the exercise, and the exercise is going to stop on number 8. So try as much as possible to simplify them. Now just a reminder, I told you things in this format, you first rationalize them individually. After that you add. Rationalize individually each and every fraction. After that you add. So this one is mainly multiplication, so try to simplify it as hard as you can. Now looking at indices, we are going to say that an index is going to be a power to any given number. For example, if you're having x to power y is going to be a power, or what you can call an index, or what you can call an exponent, and x is going to be referred to as the base. So one of the laws of indices, we are going to say that if at all you're having the same bases multiplying each other, we get that base and then we add the powers. For multiplication, we unify the base and then we add the powers. So a power m times a power n is going to be the same as a to power m plus n. And if you're having a to power m divided by a power n is going to be the same as a power, the difference between the powers. For division, it's going to be m minus n, but for multiplication, it's going to be m plus n. And if at all you're having powers multiplying each other in this format, it's going to be power, in this case, powers are just going to multiply each other. So a power m into bracket power n is going to be the same as a to power a product between m and n, where we are going to say that where m and n are going to be real numbers, but a should not be equal to 0. So from these variable laws, we can also deduce that any number to power 0 is going to be 1. I hope you know that right away from your O level. And any number to power negative n is going to be a reciprocal of that very number. So if you're having a to power negative n, that negative means that it's a reciprocal of that very digit. So it's going to be a divided by a to power n. And if you're having any number to the nth root of anything, it's going to be written in this form, and you're going to be looking at that in details. A similar applies to this. Now let's look at example 1. So in this example, we are going to be looking at simplifying the following indices. If you're having 2 times 3, multiplying 2 to power 4. So if you look here, we're having the same bases but different powers, and we say that to solve that, we unify the base and then we just add the powers. So 2 power 3 times 2 power 4 is the same as unifying the base, which is 2, and then you add the powers, which is 3 plus 4. So you end up with 2 power 7. If you're also having 5 power 7 divided by 5 power 2, we unify the base, and then for division, we just subtract the powers. So it's going to be 5 power, a difference between 7 and 2, and you are going to end up with 5 power 5. Now for part C, you're seeing that you're having both multiplication and division. So here we are going to use the same laws. So for the first of all, we have a multiplication and division. So since we're having the same base, we unify the base. And then later for multiplication, we add. So that's why you're seeing that you're having the powers to be -2, summation between -2 and 5. And then for the division between 5 and -3, we subtract. So that's why you're seeing minus this -2 which is present here on this 3. Now if you put everything in the calculator, you're going to end up with 5. So that's why you're seeing here we are having our final answer to be in terms of 3 power 5. And you want the answers to be in this format. Don't try to simplify them. So you can see that here we are having numbers that can be simplified into indices. So 32 is the same as 2 power 5. Also, 243 is the same as 3 power 5. So we say that a number outside of this, for us, since all of these things are having uniform powers, we can pull out the 5 outside the bracket. So we shall end up with 2 over 3. So we shall pull out the power 5 since both of them are having it, and then also this one is raised to the power of 3 over 5. But you have said that if at all you're having a power multiplying a power, they are going to multiply each other. So that's why this 5 and this 5 cross away, and then you end up with this fraction of 2 divided by 3 power 3. Now this is going to be the example, which is also in the same explanation. Now let's look at another format of indices or another format of examples. So with this, you are being provided with the following questions. So in the following questions, you are supposed to find or to calculate for the value of x, and I believe that you have came across multiples of this. We are going to be setting them in items in a specific format. So if at all you're having 3 power x, what you have to know is that you have to first simplify all the digits, the bigger digits in terms of in this format. So 27 is going to be the same as 3 power 3. But it told you that if at all you want to take a number upwards in the numerator, then that means that the power has to become a negative. Or if the power was negative before, if you take it up, it has to become a positive. So 3 power x is the same as 3 power negative 3. This 3 power negative 3 is the same as 1 out of 27. So since we're having the same basis, we just equate the powers. I hope you have understood that. If at all you're having the same base, you just equate the powers. It's going to be the same as x being equal to 3. Now if you look here, 32 is the same as 2 power 5. So that's why in part B, the solution, you're saying that 2x is going to be the same as 2 power 5. Since you're having the same basis, you just equate the powers. So it's going to be x to be equal to 5. Now in part C, you're having 381 is the same as 3 power 4. So since we're having the same basis, here we also just equate the powers. That's why you're seeing that x plus 2 is going to be equal to 4. If you take 2 this side, it's going to be x to be equal to 4 minus 2, and then you're going to end up with your final answer to be 2. Now if you look at part D, here's where the signs and these ones are going to be the most commonly said questions. If you look at part B, you're having 2 power 2x. So what you do here is that we first extract, remember that this is a multiplication of 2 powers, and you have looked at this law. So you first take 2 outside the bracket, and then you end up with 2 power x, or all of it into brackets, and then we take one of the powers outside. In this case, we take a digit, which is going to be 2, multiplied by 3 into 2x plus 2 being equal to 0. Now when you reach this step, you let 2x or that value having an unknown power to be equal to any unknown. So in this case, our 2x is going to be equal to y. So when you substitute it, you're going to end up with y squared minus 3y plus 2 to be equal to 0. Now this is going to give you a quadratic expression, so you have to factorize it completely. And then you're going to end up with y minus 1 into y plus 2 being equal to 0. So either y is going to be equal to 1 or y is going to be equal to 2. So you bring back the value of x. So when we bring back the value of y, it's going to be 2x to be equal to 1. And with this 2x, any number raised to power 1, any number raised to power 0 is the one which gives us the answer of 1. So that means that the value of x is going to be 0. Now the same applies to this. If I tell you 2x is equal to 2, that means that x is going to be equal to 1, because we're having the same, or we're having uniform basis. Now we use the same concept here. Now dot in pure mathematics means multiplication. So you may see it somewhere and you get frightened. It means multiplication. So here we do the same thing. On this, now remember that here we are adding 2 powers, and in addition, indices means that you are multiplying the same basis. So that's why in the solution we first separated them. You are seeing that it's 2 power 2x multiplying 2 power 1 plus 5 into 2x, then minus 3 to be equal to 0. And then we also simplify this 2 power 2x the way we did it in the first example or in the previous example. So it's going to be 2 into 2x, and then we take the digit outside, which is 2, and then you remain with your equation to be in the following format. Then you let 2x to be any other letter. In this case, I was using y since it starts my name. I like using y, but you may also use any letter of your choice. It's not fixed to y. So you are going to get a quadratic expression in this format, which you have to factorize and find the two different values of y. So factorizing the quadratic, we are going to end up with bracket of 2 minus y into bracket of y plus 3 to be equal to 0. So either 2y is going to be equal to 1 or 2 power x is going to be equal to, if you make y the subject, you're going to get y to be equal to a half. So you substitute back for the value of y, which is 2x. So 2x is going to be equal to a half. Now there are two ways of solving this. Sometimes you may use log, you may introduce log, or you may do the way we are doing here. So a half is the same as 2 power negative 1. So since we are having the same basis, you just equate x to be equal to negative 1. And if I tell you y is equal to negative 3, here I said NA, but it's going to be, just say that x is undefined, because if you introduce log, your calculator is going to give you math error. So in that case, you just say the value of x is undefined. Now let's look at the complex examples in Roman number 3 and their solutions. So let's start with part A. So part A we first start by solving. Now if you look here, if you look at part A, first of all, we are having this root which is raised to a negative power. So for us to get rid of that negative power, we have to take it down. We have to take this bracket which is raised to a negative power down, and then you're going to end up with this expression. So here I also had to make this one a fraction by dividing it by 1, which doesn't make any sense, but for us to get LCM. So getting LCM in the denominator is going to give us this in the numerator, and then later you are going to multiply this with 1 plus x. But I missed some step here, so it's going to require a smart student to first do some side work, and you see how I go to this step. But for any confusion, I say that you state out your confusions in the comment section so that you can improve on the presentation for those ones who may not see things quickly in the next video. You present your issue in the comment section. So after simplifying, you're going to end up with this in the numerator and with that in the denominator. So here we don't expand the denominator, we just simplify the numerator, and then you're going to end up with the following answer. So this one is going to be the same explanation, but it's going to be your task or assessment for you to follow up and see where. Now here, this is the final answer, but you had to simplify this by dividing both of these two so that you can end up with 1. Now let's look at an assessment that you're going to have for indices. So these are the numbers you're going to try out under the concept of indices. Like I said, if you're having any issues, now here I provide the answers which you're expected to get. If you're having any issues approaching the questions, leave the issue in the comment section or reach me out directly. So let's meet in the next video, which is going to be about equations under pure mathematics.